Okay, so we got a 2005 Chevy Envoy. It is the 4.2 motor, and it had a code. Bring you over here to the scan tool. It says P0480 cooling fan relay 1 control circuit. Now, when we go over here, well, I'll show you on the car actually. This isn't an electric cooling fan. Get you some light. It's a fan with a viscous clutch, and it's electronically controlled. So it'll have a 5-wire plug. There will be 3 wires for a Hall effect sensor, and then 2 wires that will provide a pulsed power. And all of that will do is we'll thicken up the clutch a bit so that when it's not powered up, it'll just kind of freewheel and it'll act like a normal viscous clutch. But what it can do is it can power it up and make it solidify more, so it can get a little more of an an overdrive, so it can spin faster than the engine speed when it needs to. It gives it a little bit of control over that. Okay, so I got us a wiring diagram. So first thing I'll do, since it was for the fan relay, is I'll just start going through the wiring diagram and just look for a fan. I'm not even really reading anything, I'm just casually going through, look for anything that kind of seems like a fan. So we got our fuses, our power sources, we got some sensors, actuators, not fans, HVAC, blower. Okay, so this is just the air conditioning kind of stuff. We don't care about that one, we don't need that one. Let's look at this one. We got AC compressor. Hey, there's a fan relay, underhood fuse box, and we go there. Our cooling fan 4.2 front of engine. That would be the one. And then down here, this box, it's powertrain control module. Then if we look over here, we got some other junk. I'm not too concerned about that just yet, but we got a fan relay. We'll take note that the relay above it, where it shows the field coil and it shows the actual switch, that one is done as a normal diagram, whereas the other one's just a black box. Kind of makes me think that this fan relay would be solid state and not a regular relay. Also, we'll notice that the terminals are a little different, so we'll take a look at that when we get there. So if we follow wire 2, it goes up, then it says a fuse 20, 10 amp. We could look at that. Right now we're just kind of gathering some data, kind of figuring out what we want to do, what's quick test. But yeah, for sure we could look at that fuse. It's easy. Probably not the case, but maybe we'll get lucky. Well, if we follow pin 4, that comes down to the cooling fan controller, and then it goes through, then it comes back out on A, the black wire, and that's a ground, a full-time ground, and then we have the Hall effect sensor, which gives the computer the speed feedback. So we know that we got some grounds we can check, we got that fuse we can check. This says underhood fuse box, left side front of engine, which would house that relay, which is relay 45, and a fuse, which is fuse 20. And then we already know where that connector is, so we could look at that. For right now, let's grab the scan tool, we'll hook it up. We'll see if we can see some bidirectional controls or any live data or anything that might give us an idea of things without having to dig into stuff. Start with what's ever easiest. So we're back. We're in our vehicle. We got our wiring diagrams with us. You never know if we'll need it. Possibly. We got our scan tool. Probably just leave it right there. Maybe that'll be okay. Got our vehicle. Turn the key on. Shut up. Back over here. It's gonna make all kinds of noises. Diagnostics. We already got the vehicle loaded. Trouble codes. I ran it for bits and see if the code came back. Oh, hey, look at that. We do have a code. That's good. Hey, same code. Okay, it did come back. That's good. I did clear it. If I'm dealing with a misfire, I won't clear codes. If I'm dealing with something such as this, a device of some kind, usually I'll clear codes. So let's try active test. It's probably going to want me to fire it up. Active test, engine, viscous fan, click that. Okie dokie. So we got an option down here, decrease, which is grayed out, and then increase. Up here we have fan speed. We can see it's reporting at 176 RPMs. Desired fan speed is at 304. We do see that the fan speed is moving. So let's try revving it up. Looks like it's got a little bit of a slow delay. There we go. Either way, you can see that the fan speed is reporting and it is changing, so one would think that that's probably accurate. Plus the code was for the control side, which would be the 2-wire that actually provides the pulse power. So let's try increasing this, see if we can increase it. Okay, so desired now is at 520. We'll notice the fan speed, the actual, hasn't changed. We're at 624 for desired. Let's try bumping that up quite a bit. Let's go. Alright, so we're at 70% is what it wants. Fan speed, still saying 160, 170. Desired fan speed, 800 something. Try revving it up. So now we can see desired fan speed is quite a bit more, but fan speed hasn't changed one bit. So now desired, we're getting close to 2000. Okay, we can, well, just for grins and giggles, we'll try decreasing that. See if our fan speed changes any. Probably doubtful at this point. Nope. Okay, let's get out of there. See what else we can do. How about some data? It's always good if you do a bidirectional test, you never know if that enters the computer and devices into a certain state because it's not really in its native environment. You're telling it to do things. So it's good to back it up with the vehicle running under its normal state. 3. Let's go with 3. I don't know where a fan would be, so bring that down. Click over there. FAN. Hey, look at that. We got lucky. Show selected. There we go. Okay, well, we can get rid of that. There we go. Okay, so right now this is showing the same sort of deal. Desired fan speed 304, fan speed 144. Now what else we can do, instead of bidirectionally commanding it to go up, there's also air conditioning. Let's turn that on. So we got air conditioning on. It's cold. It's probably gonna be really noisy, but it's running. We heard the compressor click. It does feel cold. So we go back down here. I don't know if you remember, but this used to say 300 or so. Now it says 500. Because as the air conditioning is running, we're at 566, 600. as the air conditioning is running, the high side pressure is getting higher, and pressure is related to temperature, so that's getting hotter. So the condenser in the front has to dissipate that heat. So the vehicle is sensing that the pressure in the air conditioning is going up, so it's saying, hey, turn on this fan a bit more to get rid of this heat so we can make our air conditioning work properly. But you'll notice how this is going up, the desired is going up. Let's try revving that up more. It's going up, and fan speed not changing one bit. So we can look at that. What do we say? Fuse 20 is 10 amp. So we look on here, fuse 20 is right there. So there's a big relay right there. There's fuse 17, fuse 18, and then 20 is one over, kind of does an L shape. And let's take a look to see if we can see that. Okay, there's that big relay. There's a 10 amp. There's a 10 amp directly below it, and then one over is a 10 amp right above that 15 amp. So that would be our fuse. Wouldn't that be something if that's burnt out? I'll go over here. It's been a day. It's been a day. I did have this organized at one point, but life moves on. So our other end, the test light, goes negative. And, just gonna move you all around. So we are test light. We always want to check our equipment, but you know what? If it lights, then that's checking our equipment anyways. So it's lit. So we know that our connection's good. If it didn't light, then absolutely we would want to go over and put it on some power and make sure that our connection's good. But since it lights, we know our connection's good. Go to the other side. Okay, both sides light. So we know that's good. Perfect. Now, if we go back over here, we are looking right there. Fan relay 45. Look at those black guys. They look a little different. Bet you those are them. 45 right there. 41, 45, 46. This guy. Let's pull that off. That's different. Yep, and definitely solid state. So really what I want to do, rather than going after the relay, I'm just going to go down to that connector because it's right there. There's a connector right there. And on our wiring diagram, we see A, B, C, D, E. C, D, E are a sensor. We don't care about that for right now because it did appear that was working. So that's a gray, followed by dark blue, followed by gray. And then A is a black, and then a white. So that should be pretty easy to spot, black and white. Well, I didn't realize that it actually turned the recording off. Thankfully, I didn't miss too much. So we were at the connector. We're gonna start with checking the ground. That's the easiest. Remember, black was on the outside. White and gray might be a little hard to spot, but black was on the outside. So here's a black. It's the only black. The very next one's white. That is our power feed for the fan. So these two don't really look that different, but the next one after black is a power feed. Let's start with black. Try to get this guy in there into a nice spot. Now, when you're back probing, you always have to assume that there's a possibility of not making connection. So if you see something light up, so say if I test this ground and I find a good ground, then hey, I know I have contact and I know my ground's good and I can move on to the next. But if it doesn't light, you have to assume first, rather than assuming it's a bad ground, you have to assume you're not making contact. And you have to do things to verify that yes, in fact, you actually are making contact. You can go back into your back prober, wiggle it about, see if it lights up at any point in time. Otherwise, what you can do, if you know the other side is a good power, you can switch it around and see if you unplug it and see if you can see the power, or sorry, not unplug it, see if you can see the power, but you could unplug it and hook up a multimeter and test the resistance or continuity between this spot and the front of that terminal. Then you know absolutely you're making contact. But rather than just saying, okay, yeah, we got a bad ground and running down that rabbit hole, make sure you actually are making contact. If you don't see anything, if you see a thing, then you know you're making contact. Anyways, long-winded. We're looking for a ground. We got a test light hooked up to a positive because we're looking for a ground. We can verify that. Yeah, it lights. So now we can shove her in the hole. And it lights. So our ground is good. We know our ground is good. Let's go to the next. This one, I don't know for sure, but since it is a solid state relay, I would have to assume it is pulsed. Duty cycled of some sort. You can't duty cycle a mechanical relay, but you can duty cycle a solid state relay. So we won't be using the test light. We'll be using the lab scope, and we'll need our wires for that. Oh my, I didn't say you could do that. Wait, what do we got? What do we got? Aha! So we'll hook that up to ground. Now, these side posters aren't awesome, so we have to be more than aware that that could jump off before we assume, oh, we don't have contact or we're not seeing a signal. And then our other guy, we will get down here. And hello. And if we can plug that in, come on, you can do it. Heck yeah. There we go. And we will also need our lab scope. We'll just throw that hunk of junk in there. It's only a few $1,000s. Come on. It is, in fact, impossible to keep your leads untangled. Usually when you're done a diagnosis and you need multiple wires, you end up with just a mess afterwards. I do, at least. Maybe that's just me. Oh, I left the key on. Hopefully we still got battery power. Being a Chevy, you know. shut that off and save whatever. Oh, now you're gonna be dinging. Gonna be dinging. Okay. So our lab scope. Let's see if we can hook up. There. There. These guys. Oh, she's gonna be gnarly. Well, I'm actually gonna fire that up. Just to make sure I have juice when I need to. Okay, let's go back to our relay. So here's our connector for our fan. We verified that the ground is good. Here's our relay, we know where that is. We verified that the fuse is good. We didn't verify that the fuse power is getting there. We didn't verify the ground for that or any of that. I'm going to bypass all that stuff, and I went directly to the output of the relay and the wiring all the way to the connector. That's where I'm plugged in. So I'm going to check to see if I see power there. If I see power there, then I know that the ground will be good. I know that the wiring will be good. I know that the power supply will be good. I know that the relay is good and the control and all that. Not uncommon at all for these to go bad. So go right there and we'll see what we see. So on our lab scope, put a bit of clear scope. Yeah. See if I can't make that any better. Not really. Yeah, well. We got lab scope, graphing meter, digital multimeter. We want graphing because we're not going fast. We're just gonna go slow. So we want, yeah, we'll take filter, definitely not peak. We got voltage, 20 volts, 10 seconds. Yeah, that seems about appropriate. So we can see right now it's at 0. So the relay is not being turned on. Go back to our scanner, hit escape. Let's go to the active test. Why not? Engine, viscous fan. Vehicle is running. Let's see. Uh-oh. I heard a click. I think I know what that is. Oh, it's a side post battery. Is what that is. Wow. You little. Yeah. Well, I think we can make you stay. Doesn't need to be on there that long. Alright. Okay. Oh, we're just about ready to do the test. And of course it has to jump off. Okay, so let's actually switch these around. Alright, that looks better. So we can see background is turned off. We're at the fan. So let's see what happens when we increase it. Nothing, it's still off. So going into this, I was totally expecting the fan to be bad, the fan clutch, and I was expecting to see a signal down at the connector. That's why I bypassed the relay altogether, but I don't see anything. We've commented it on. Bidirectional control. Again, always assume if if you command something or if you do something and you don't see any result, always assume that what you did wasn't adequate. So say you're back probing and you don't see your test light, expect that you're not making a connection. You command something on with a bidirectional control and it doesn't activate, assume that your scan tool isn't communicating properly or is programmed properly or the vehicle's ignoring it or whatever. Always good to back it up. Obviously, if we hit increase and we saw a corresponding rise, then we would know it worked and we see our signal and we would just need a fan. But since we hit this and we didn't see anything, we're going to do another thing to see if we can command that up. So we'll get out of there. We'll go back to our air conditioning. Engine 3, I think that was. Judgement. Fan. My number one. Not fam. Fan. Oh my. Okay. So we can already see that it's got a disparity, so really we should see something there. But let's turn the air conditioning on. Okay, we heard the compressor click. Alright, we can see the desired rising, but we don't see anything there. Now we're gonna go out, we'll check to see, shut that off. We can check to see that our alligator is still on ground, and then we're going to start looking after that relay. Maybe we just have a bad relay. Wouldn't that be special? Okay, so we can see that we're in there, so that's good. You know, another thing we can do too, let's grab our multimeter. Let's go back inside. Oh, I don't mind that mess. I need a cleanup day. Okay, so to go back to our wiring diagram, our back probe is into B, the power side. The other side, then we're grounded. So what we could also do is we can check the resistance of that coil. So since our test lead, the yellow one, is on the power and the other side's attached to ground, we could just go directly between these two. Now when you're testing resistance this way, you want to unplug it from your scan tool or your lab scope, because you don't want to allow the possibility that your lab scope is providing a different path, because ultimately it will be a different path. It should be incredibly high resistance, so it shouldn't really be affecting anything, but it's a good idea. Pop one of them off. That way we don't have to worry about that at all. Shove that in there. Okay, so now we'll see what we see. And we are flying all over the place. You know what that means? That means we're probably not making connection. Back out. Oops, didn't mean to turn you. Wait, let's see what's happening. Anytime you see something flying all over the place, then that means you're not making connection. So let's see if we adjust our ground. If that improves anything. And it does. Somewhat. But you'll notice, ignore the minus sign, you'll notice that's million ohms. So that's basically open circuit. Let's grab another light. Put you down there. Let's see if we can't also put you in the picture. Okay, you'll see how steady that is. That means, with that being that steady, you know, in order to do a proper resistance check, really should unplug this relay in case that's affecting the circuit. Yeah, it wasn't. But let's go down there. Now, see how it's not really moving? That would indicate that we're making a connection. Otherwise, it would be moving. But so, and that's so much resistance that I do believe our fan is bad. Okay, we went back there and you'll see 0.843 million ohms, so that's 843,000 ohms, 843 kilo ohms. Now we're going the roundabout way, but if we wanted to, we know that our ground is good, so we could just as easy get another stabber, finger poker. Let's do it. Put that one on the ground. Okay, our other multimeter lead, we can unplug from there. No, sorry, keep that one plugged in. Because that's yellow. I'm going to unplug the one from the black. And I'm just going to try and, you might not see that very well. Oh my. Yeah, I know, my hand's in the way. What you gonna do? So now we see, oh well. So let's adjust those probes until we make contact. You can see it's sticking out so far that it doesn't feel like I'm making contact. Wait, that is much better. Maybe my ground wasn't good, or who knows, maybe my scope lead's not good. But if we look at there right now, we can see 9 ohms. Now, this is a circuit that's supposed to go through and thicken up the viscous clutch a little bit. It's a little bit of a heater circuit. Therefore, I would kind of assume maybe a little lower than 9 ohms, but I doubt I will be able to find a resistance measurement for that, and who knows, maybe 9 ohms is good. But what I still want to see is I want to see a power input on that white wire. We know 100% certain we're making connection right now. And we know that's our red back probe, which is attached to our yellow scope lead. We know that that's making connection. So I'm going to take this off and I'm going to see if I can get a better ground maybe. Or unplug this. Done with the multimeter for now. Throw that off to the side. So we want to find activity down there on the yellow wire. Make sure we are still in that yellow wire. Nice. We are. The white wire, I mean. Let's grab our test light, and what we're going to do, our test light's on battery positive, so we're going to go on the end of this black wire. Okay, so we do know that our wire as well as our alligator is making a good connection. So at this point where I'm going to be plugging into the scope, it's a good ground. Now our yellow wire, that goes through roughly 10 ohms and then goes to ground. So I don't know if this will light my test light. Oh, it does. Okay. So we know that this has got a good connection and it's going through the coil inside the clutch and then to ground. So we know that both of our leads right now are making good connection, and whatever it says on the lab scope, we can trust. So we can take our relay, plug that back in. And when you're trying to diagnose things, this happens all the time, that you do a thing and you get a result you're not expecting. You have to go back and verify your equipment, only to find something popped out or you weren't making a good connection or whatever. That's the nature of the game. It's frustrating. Sometimes it doesn't happen on a test, but more often than not, it does. Alright, so let's get these back in there. Okay, make sure it is still recording. Okay, so we saw numerous times when we turn the AC on, the engine computer is asking for more fan speed. So we don't really need our scan tool right now. We'll just turn on the AC. Fire up the vehicle. Okay, I'm gonna turn on the AC. We're going to watch that. Okay, AC's on. We heard the compressor click. Give that a moment. Now I don't see that. I don't see any signal. There's no change. So, and we verified that our connections are good. So now we really do need to go back to that relay. Shut that off. Back outside. Oh, shut up. Wait. And over this way. So let's start poking. Yeah, gimme. And we'll go back to here. Now, what we can do Oh, I shouldn't do it. Oh, Nelly. Yeah. Oh, $8,000 scope. Well, you know, should be rugged if it's a shop tool. All right, where were we? Here's a relay. Let's get this junk out of the way. Pull you out. Get some illumination if we can. So we are looking. What can we test? 2. Is there power? Okay, let's see if we have power on 2. Thankfully there's a diagram. We don't really care about that. Mainly we care about our numbers. Where is, that's 5, that's 4. This one is 2. So if we go back here, fingers right there, goes there. So the near side, the one closest to me, is 2. Go back. Sure enough, that's 2. So the one nearest me should be power. So our test light, yeah, looks like a ground over there. I'll put this guy gently down in there. And unravel that a little bit. And I did not mean to drop that, but yeah, I'm gonna have to get you close. Oh, and you know what? Turn the key off. What a dolt. There we go. Oh my, why is the air conditioning on? No, we're really gonna kill the battery. Okay. Believe it or not, I do have a plan. Okay, again, the lights, we're testing for power. I'm kind of coming off there a little bit, plus I'm not in there. Very good. There we go. Solid power. So that means the power is good. We don't have to check our connections. We know that's good. Next, our ground. G108 comes up, and that is focus 6. Yeah, 6, kind of a bad printer, but 6. 6 is ground, because a 6 kind of looks like a G, I guess. Alright, so this one here, the one by itself, is ground. You stay. So our test light, we switch over to ground, or power I mean, because we're looking for ground, and this guy is the one by itself. I won't be able to stick that down there, so we'll use this guy here. Really look close. This does take half a second with 2 hands, but what if you only have 1 hand? Alright, this is lighting. So that means the ground is good. It's kind of coming and going because I'm just gingerly touching the back prober on the contacts. So I don't want to spread the terminals. So we know that the power and the ground are good for this relay. That leaves the control side and the wire down to the fan. So now what I'm going to do, since we know we're into B, and that we know through 9 ohms or so of resistance, which does light my test light, it does find a ground. So I'm just going to put into 4 my test light and look for that ground, because I'm already on power anyways. So 4, one of 2 left. 4 is the one opposite of the ground in the center. Okay, we'll get that ready first. Now we'll see if we can get you in there. Okay, it's lit, and that might be hard for you to spot, but it's not as brightly lit as that. So, because it's going through the coil. So, we know that that has contact all the way down from there to there. So, you know what we could do? The wire from the computer, the control side of that relay, that wire could be bad. We do know that the computer is trying to turn it on, or at least it says it's trying to turn it on. So rather than testing that, because it's just a wire, it shouldn't really go bad, let's try to swap in these relays. They are solid state electronics. Solid state electronics can go. Oh, hey, my headlights went out. Put that one down there. So this one here, when I pulled it out of there, I noticed my headlights went out because the key's still on. And when I swapped them, headlights didn't come back on. That's interesting. Maybe we got a bad relay. So, put this guy back in there. Hey, look at that. So our headlights are on. Pull this out. Headlights are off. I put our other relay in there. This is the one, not the one we've been testing, but our other one. So that one was in the fan. We look at our headlights are still out. So hey, look at that. We know this is junk. But we also know that this one's good. Let's see if we get our pattern now. Okay. So we won't need this. We won't need our test light. Our wires, our leads, should I say, are ground and down there into our connector. Haven't moved, so this should still be good. Can pick that guy up. Go back inside yet again. But I think this should be about the last time. I think we should be getting there. We at least know a thing. We know that that relay is bad. We're gonna have to get one of those. Oh, I'm sorry. Let's write that before anyone sees that. Hey, look at that. It still works. Good thing she's under warranty. Yeah. Don't abuse your tools, folks. Don't need to be lazy. But we're gonna be anyways. Okay, so let's just see what we see. We fire it up and we'll turn our air conditioning on. Anything? Hey, whoa, look at that. Look at that. We got, and it's up top. So we got control. That's reaching the fan. So we know the computer's doing its job. Let's see if that fan's working now. Uh-oh. Fan speed 160. Desired fan speed 730. But we see the control. Let's see what happens when I turn that off. Nah, it stays up anyways. But we noticed that turning it off The desired has gone down, but our fan speed's still not meeting desired, and power's still all the way up. So that fan speed should be spinning faster. Could be that both are bad. Let's turn that back on. Rev it up a bit, allow it to. So 700, 800. Our fan speed is going a little faster because remember, we trust the sensor, the speed sensor in the fan, and just by revving the engine up more, oh, now it's going pulsing. By revving the engine up more, we know that it's going to spin the fan faster because it'll work mechanically. And we can see it's pulsing, so that's a good sign too. That means the computer is capable of controlling things and is capable of changing things. If it were to go up and then stay up, that's not as nice of a sign as seeing change. So we believe that the computer is now fully capable of commanding this relay with power all the way down to that fan. Oh, hey, look at that! Our fan is actually speeding up. My suspicion on that is it's up to operating temperature. Remember, that is also a normal viscous fan. So as the engine heats up, it will solidify and it won't freewheel as much. It will start turning 1 to 1 with the engine. And you can see that right now it doesn't need that much fan speed, but we have more because our engine RPM is, 700 or so RPM. And now our computer is saying, hey, we don't need very much. So this is good. This is telling us that our computer is in full control of seeing the changes and working with that. And then our viscous fan is working in the sense of a regular viscous fan, but it's not working electronically. So if I were to shut that down, we see that that disappears altogether because right now desired is 300, actual is 736. If I were to shut this vehicle off like it just did, if I were to let this cool right down so that our fan clutch would go back to a freewheeling state, then we would see our computer still trying to control it, but we would see a desired high and a fan speed low. So in actuality, we do need both a new relay as well as a new fan, because the electronics come with the fan and you got no choice. And they're unpleasant to change on these Envoys. I hate these fan shrouds so much. But if we look right now, the fan clutch is really thick, so it's hard to turn because the temperature of the engine has caused the clutch to thicken up, the viscous coupler to thicken up, and to turn closer to 1 to 1. If we were to let this fully cool down, it would spin much easier, and then when the engine spun, this wouldn't spin very fast, and that is when the computer would try and command the fan on. So we need a new fan because we need the electrics and we need those relays, and then it should be good. Okay, so one thing that I wanted to do is, in the previous section, when I found out that the relay was bad and swapped them over and did get power down to that fan clutch, it still, fan speed still wasn't meeting desired. Eventually it did kick up, and I thought that was right around because it reached operating temperature and then the normal viscous coupler was working. as just a regular mechanical clutch would work. I want to make sure from a cold start, so we're at 20 degrees Celsius, that it does work. So what we're going to check to see is on a cold startup, if this fan speed does start meeting desired fan speed in a reasonable amount of time, then we know it has nothing to do with the mechanical section of the viscous coupler and it's purely the electric working, and then maybe we don't have to actually change the fan itself. Maybe it's just that relay. Let's fire it up. We'll turn the AC on. Alrighty, and there we go. We do see already the fan speed is kicking up a bit. Has dropped down a bit, so let's give it time to work. Because it is a heater, it would take time for that to kick in and thicken up the coupler. But it would take a heck of a lot less time than it would just for the engine itself to warm up enough to get it to work on its own. This car does not have an electric fan that runs the AC. It relies based on the main fan. So older vehicles that didn't have an electrically controlled viscous fan would have a secondary electric fan for when the AC kicked on and the vehicle wasn't warm enough to dissipate the heat off the condenser. So we'll just give that a little more time. See if that, so yeah, so right now the fan is starting to pick up. Probably should have put engine RPMs on this scan tool. Engine RPMs right now is 800 or so. Okay, and it has kicked up. Okay, so we see the fan speed is working. So right now it'll be slowing down. So right now the pulse control for the fan will be coming down because it's spinning faster than it needs to. When the electric heater first starts kicking on, and then when it does first kick in, it'll go a little faster than desired, and then it has to kind of settle down, find its happy medium. But we see, for those of you who like Fahrenheit, if we switch that over, it's only 125. Already the fan speed is working, whereas before that was stuck at 300 or 200 or so. You rev that up. Perfect. So it does look like we don't have to change that fan. It's just that relay, and that is happy days for me, because trying to get that fan shroud off of these 4.2s, these Chevy 4.2s, is not really my idea of fun. It's not the worst job in the world, it's just one that makes you grumpy. But yeah, just the relay, that's all we need. Thanks for watching.